Number 14 is back to an addition problem. Please do not waste your time trying to do trinomial multiplication because this is a simple addition problem. So all we're doing is combining like terms. Negative 7n squared and plus a 4n should give negative 3n squared. If you're a test taker, that goes ahead and that will go ahead and eliminate option B because it didn't have the right one. Next, we combine 6n and negative 6n. But not really because those just cancel. When we combine them, that's just 0n, which 0 times n is just 0. So we shouldn't have any n term left over, which lets me know that one's probably out and that one's probably out. Just to be safe, we combine 4 and 6 and get a plus 10, and we see that our answer shows up. Number 15, however, is a multiplication problem. There's no symbol in there, which means we're multiplying. You can either do the box or distribution. I'm going to do this one with the box method. Remember, this was the first box method we learned. 6n minus 1, 6n, positive 1. And we learned that everything multiplies to go into the box. That would be 36n squared. That would be a 6n. That would be negative 6n. And this would be a negative 1. And we learned our pairs of like terms are usually on the diagonal. For anyone that hasn't seen this before or forgot about it, look how much this mimics our factoring method. Our factoring method, we start with the things inside the box in black, and we have to factor out to get there, okay? So our final answer should be 36n squared. These are going to combine to be a 0, so all we have left is minus 1. 16 is 5a minus 3 quantity squared, which basically just means 5a minus 3 and 5a minus 3. If you did the last problem with the box method, you can go like we did right here. Go ahead and do this problem with the box method as well, but I'm going to show the distribution method. They are the same thing. Some people like one, some people like the other. So I'm going to show one of them on 15. I'm going to show the other method on 16. The distribution method means we do our 4 multiplications. 5a times 5a is 25a squared. 5a times negative 3 is negative 15a. Negative 3 times 5a is another negative 15a. Negative 3 times negative 3 is a positive 9. These do not cancel. Please be careful. Look how similar these are to the last problems. In the last problems, we had things cancel. But on this problem, we don't. We have 25a squared. These combine to be negative 30a plus 9. If you would have canceled these, which is incorrect, look what you would have got. That's a tricky answer in there, guys. But the correct answer is B, because negative 15 and negative 15 give us a negative 30. They do not cancel. Number 18 is tricky, but it's a great problem, okay? Because a lot of you look at this and say, oh, it's a trinomial. I'm going to factor it with that box method or whatever method you've been learning, okay? But this is n to the 5th power. We haven't dealt much with n to the 5th power. So I'm going to start this problem off like I start all of my factoring problems. Greatest common factor. They don't all have the variable n, so I can't pull any of those out. So I look at the numbers. A 2 will go into each of those. So if I pull a 2 out, I'm dividing a 2 out. I get 5 into the 5th power plus 2 divided by 2 is just 1n, and 2 divided by 2 again is just 1. And that's as far as you can go on this problem. What you would be looking for is factors of 5 into the 5th power that can add together to be just an n, and you're not going to find them, which tells us we're actually done factoring this problem. Number 19 is a tougher problem. It requires more work, okay? So it's 16x squared plus 12x minus 40. And again, I'm going to start off this problem just like I start off all other factoring problems with GCF. I see that I can take a 2 out of them, but I'm thinking a little bit bigger. I know I can get a 4 out of each of those, and that would be the greatest common factor. If you pluck a 2 out of all of these, you're going to be able to take another 2 out. Well, if you divide 2 out twice, you've divided out 4 essentially. 4 leaves us with 4x squared plus 3x minus 10. And now we're ready to start our box method by multiplying these outside pieces. Remember, we're done with that one now. We've made it easier. 4 and negative 10 multiply to be negative 40x squared. And we want things that multiply to be that, but add to be our middle term of 3x. Okay, so we multiply the outside ones to get the negative 40x squared, and then we're looking for things that multiply to be it, but add to be our 3x. I know my times tables pretty well, and I think immediately of 5 and 8, because that's how we can multiply to get 40. If you're not sure about all the factors of 40, remember, you can go into your calculator and type the number 40 divided by x. Look in the table and it'll show you all the factors of 40. 1 and 40, 2 and 20, 3 and that number, that means it didn't work. 4 and 10, 5 and 8. And again, my light bulb goes off that I can combine 5 and 8 and make 3. 5x, 8x. And now I have to decide because I need them to multiply to be negative. So one of them's got to be negative. And if I make this 5 my negative one, I'm going to add to get a positive 3x. So that's going to be my pair that I need. This allows me to begin the box method. 4x squared goes in my top left. Minus 10 goes in the bottom right. Negative 5x and 8x. Okay? Our individual pieces that we came up with go in the other corners. Think about when we did the multiplication last time. Okay? Our like terms ended up on the diagonal. This is the exact same thing, but in the opposite direction with factoring. Okay? When we do our greatest common factor here, we get 4x. We get 5, but because this is negative, it makes this negative. Here we just get the letter x, and here we just get the number 2. So my final answer should be 4x minus 5, x plus 2. That comes from these. And don't forget what Mr. Sorrell always forgets. This 4 that began the problem has to go out front. Okay? So that's the final answer we're looking for. Should be B. Now, I'd like to take a moment to point out, B does not look exactly like my answer. Look, I've got mine in reverse order, and that's okay. It's just multiplication, okay? You can write these 3 terms as long as you keep the things in the parentheses in the same order. You can write these in any direction you want. So the test has x plus 2 first and 4x minus 5 second. That's okay. Heck, if you really wanted to, if you were just into really making things look terrible, you could probably get away sometimes with writing it like something like this. Please don't, because this looks god-awful, but it's not really wrong. It's just a different way to show you're multiplying everything together. Don't ever do that. Just saying. Don't write it like this. But all 3 of these things are commutative because they're just being multiplied together.